Okay, so in this video, we're going to work out a Java free response question. We'll start by reading through the problem, and as we're reading through it, I'll make some comments, and then we'll work out the problem. A multiplayer game called Token Pass has the following rules. Each player begins with a random number of tokens from 1 to 10. So random number should stand out at us. We have to generate a random number here from 1 to 10. Notice the square brackets on the end. That means you include the number 1 and you include the number 10. And the parentheses here say at least 1, meaning equal to 1 or more, but no more than 10, meaning equal to 10 or less. And these numbers are placed on a linear game board. There is one position on the game board for each player where there are n, where n is the number of players, so we have n players in the game. After the game board has been filled, a player is randomly chosen to begin the game. Each position on the board is numbered starting with 0. So when we see that, we should say, well, if we start at 0 instead of 1, and there's n players, that means the player positions are going to go from 0 through n minus 1. That means if we had 4 players would be 0, 1, 2, 3. We see that there's 4 positions there. So because they're starting at 0, we understand that the highest player index will be 1 less than the number of players. All right. So then we go on to the next section, which says the following rules apply for each player's turn. The first rule, the tokens are collected and removed from the game board at the current player's position. Next, the collected tokens are distributed one at a time to each player, beginning with the next player in ascending order of position. If there are still tokens to distribute after the player at the highest position, otherwise known as the end of the board, gets a token, then the next token will be distributed to the player at position 0, meaning the beginning of the board. The distribution of tokens continues until the current player has no more tokens left to hand out. And now we're at the last section reading. The token pass game board is represented by an array of integers. The indices of the array represent the player position of the board, and the corresponding values in the array represent the number of tokens that each player has. And we're going to look at an example that illustrates this for us. The following represents a game with 4 players, and the player at position 2 was chosen to go first. So the tokens at position 2 are collected and distributed. That means if we collect them, player 2 has 0 tokens on the board and must hand out 6 tokens. And we see here's the first, second, third, fourth, fifth, and 6th token. So if we follow through here, the first token goes to position 3. So we'll say +1. We're at the end of the board, so we have to go to 0. And we will hand a token to the player at position 0. So far we handed out 2 tokens. Handed out 3 tokens. Now player 2 gives themselves a token. So that's 4 tokens. Hand another one to the player at position 3. That's 5 tokens. We're at the end of the board. Go back to the beginning, and there's our 6th token. That means that after player 2's turn has completed, position 0 has 5 tokens. Position 1 has 3 tokens. The player at position 2, whose turn it was, now has 1 token. And the player at position 3 now has 12 tokens. We see this is after player 2's turn. This is before player 2's turn. We just have them both together so we can compare what the board looked like before and after the turn. Remember, when it was player 2's turn, those 6 tokens become 0 on the board, and then there are 6 to distribute. So now this brings us to the actual coding part. here it says that the token pass game is represented by the token pass class. So we see that we have a public class token pass. And right away you see there's private variables being declared. We call these instance variables because they get initialized when a token pass object is instantiated. That means don't forget to include these in your constructor. So this is the comment for the token pass class. It says create the board array to be the size of player count, and it fills this board with random integers from 1 to 10, inclusive. Inclusive means including the number 1 and including the number 10 means including those endpoint values. Then it initializes the current player variable to a random number, again, not random integer, whose value is between 0 and player count minus 1, inclusive again. And the parameter here is the player count, so how many players are playing the game. So our token pass class will be part A of the question. And then we have a part B of the question, which is to create the distribute current players tokens method. So to distribute the tokens from the current player's position one at a time to each of the players in the game. Distribution begins with the next position and continues until all of the tokens have been distributed. If there are still tokens to distribute when the player at the highest position is reached, the next token will be distributed to the player at position 0. Now, reading this over and over, it brings to mind, how do I count and keep going back to zeros? And this is something you learn in an abstract math class, and it becomes very useful in computer science. And we're going to use modulus. Modulus will be the most efficient way to increment and go back to 0 when necessary. You can do it with if-else statements as well, but the quickest way to address increments that go back to 0 is using modulus. So remember that. Increments that reset to 0 is modulus. Okay, so we will look at the precondition. That means there's a current player that has at least one token, and a post condition, the current player has not changed. So the code for this is not going to identify who the next player is. It's just going to distribute the tokens. All right, so here we are for part A. Write the constructor for the token pass class. The parameter player count represents the number of players in the game. The constructor should create the board array to contain player count elements and fill the array with random numbers between 1 and 10 inclusive. The constructor should also initialize the instance variable current player. So we need to initialize this as well. And that must be a random number again from 0 to player count minus 1 inclusive. Here is our comment that is provided to us with the class we're about to write. So I'll put my initial brace here. Create the board array to be the size of player count. Now I'm going to go back to my class description. Here's my class description. And once again, I have an integer array called board. It's already been declared. I don't need to declare it again. I just need to instantiate it. So I'm going to take these two with me. Okay, so this is where we're going to write our code. Part A, write the constructor for the token pass class. The parameter player count represents the number of players in the game. The constructor should create a board array that contains a player count number of elements and will fill the array with random numbers generated between 1 and 10 inclusive. That means include 1 and include 10 as options. The constructor should also initialize the instance variable current player to a random number between 0 and player count minus 1 inclusive. That means we include 0 as an option and we include player count minus 1 as an option. Complete the token pass class constructor below. So we see the constructor signatures here, public token pass, and it has a parameter, which is an integer player count. And player count is going to determine the size of the board. Now, up here in the corner, I just wrote down the instance variables that were given to us when the class was described to us. So we see that there's a private int array board. It was already declared. We only need to initialize it. So we're going to say board equals new int array with a size of player count. And in the example that we saw illustrated, there were 4 players, so it would make a new int array with length 4, and that would give us indices from 0, 1, 2 to 3. All 4 of the players would have a position. Now we need to populate this array as well. So we're going to use a for loop to populate it. So for loop integer variable I will start it at 0 because our initial index is 0. And we will let I go up to player count. Notice I'm using a less than so that it cannot be equal to player count, but up to 1 less than player count. And we will increment I 1 at a time, and that will traverse all of the index values for our board. Now we would like to populate the board. I'll say board at position I equals. Now we have to generate random numbers, and they have to be integer values. So we have math.random that we can use, but that generates a double from 0 to 1, square bracket on the left, parenthesis on the right. That means it goes from 0 through 0.999 repeated. So we're going to multiply that by, we can populate from 1 through 10. So we're going to multiply it by 10. So 10 times math.random. That will give us 0 through 9.999 repeated. And if we cast it with an integer, it will result in 0 through 9. So we're almost there. We just have to add 1 to our expression. And that will give us 1 through 10. And those are the numbers we want to be able to generate. So we're going to put an integer cast, and then I'm going to say 1 plus 10 times math.random, parentheses, because that's a method, parentheses to close my expression so the whole thing gets cast to an integer, and end my statement with a semicolon. That's all I need for the for loop. Since it's only one line, I don't need to use my curly braces. And my next line will be current player. And again, I need to generate a random number. So equals, it's got to be an integer because it's an index. And we're going to use player count times math.random. So this was my scratch work over here. You should always have scratch paper so that you can figure things out, how you're going to have to adjust your mathematical expressions so that they will be able to accomplish the tasks that you're looking to do in your code. And this would be the answer to the token pass constructor according to the expectations laid out for part A of the question. Now we can go on to part B. So again, I put a bunch of stuff from the class page so that I have it easy to reference to. I have a token pass class, I have a board and a current player instance variable, I have a constructor that I just defined, and right now I am going to define the distribute current player tokens method. And to do this, let's read through the instructions. It says write the distribute current player tokens method. The tokens are collected. This is the tricky part. Collected, that means you need to remove them from the board. You need to set the board back to 0 for that player's position, but still hold on to the number of tokens in memory that you collected from the board. So the tokens are collected and removed from the game board at the current player's position. These tokens are distributed one at a time to each player, beginning with the next highest position until there are no more tokens to distribute. And when we read through the instructions, when we get to the highest player on the board, if we still have tokens, we have to go back to the 0 position. And I said this would be best handled with modulus. I will write the code with modulus. You can write it with if-then statements and see that you can accomplish the same end result either way. So we're going to start by saying let's collect the tokens from the board for the current player. So I'm going to say int tokens. I'm declaring a variable to hold on to those tokens equals. We're going to go to the board and access the location of the current player. And now those tokens are in memory. So now I can take that current player's position and I can set it to 0 because that player no longer has those tokens on the board. Those tokens are now being distributed. And we'll say for int I equals 1. So why am I using 1 and not 0? Well, I'm going to take the current player's position. So if we're at position 2, I want to add 1 to get position 3. And then when I take the current player and I add 2, that'll give me 4. Now, in the image given earlier, we had a sample board that went 0, 1, 2, 3, and then we had to go back to 0. Well, this is where the modulus comes in. If we divide it by the length of the board, 3 modulus 4 is 3. 4 modulus 4 is 0. Remember that modulus is what is the remainder when you do integer division. So if I'm at the current player's position 2 and I go 3 tokens down, that's going to give me 5 with a modulus 4, if that's the length of the board. Well, that's going to be 1 remainder 1. The modulus just reports back the remainder, and that means player 1 would get a token then. So again, this is my scratch work here. You should always have scrap paper that you can put your ideas down on and figure out how to get the code to accomplish the things that you want it to. So I started my I at 1, and then I'm going to say let my I value go up to and equal to the number of tokens I have to distribute. And I will distribute 1 token at a time. So I'm incrementing by 1, I++. And now I will add those tokens to the board players. So I'm going to say current player plus I modulus board length, because the board length will give me the number of players. And I will increment it by 1 and close my method. And that is the answer for part B of this question. So we've answered all of the parts. Our code will accomplish all of the tasks. And We made sense of the problem reading through it. We highlighted things through it. We have to know certain things like instance variables and that they need to be instantiated in a constructor. And it's always good to have scratch paper to put your ideas down on, work them out a little bit by hand, see if they make sense and accomplish what you want them to before you put them into code. Okay, so I hope this example is helpful.